Okay, so my name is Gaëtan Marceau-Caron. I'm part of the Mila Tech Transfer team. I'm an applied research scientist, and my job is to take new techniques, science from all the literature research in machine learning, deep learning, and try to adapt it and to help people in the industry to use it for their own project. Because it's not true that we can just take a paper and try to apply it to our data and it will work in 1 week. It's something that takes time and also requires some techniques and methodology. And my objective today is to present you this methodology, especially in this first presentation. Okay, so the first thing I want to cover is the difference between artificial intelligence and machine learning. Nowadays, we are using these two terms to refer to the same techniques, but actually it's not true at all. So artificial intelligence is about how to simulate intelligence on a machine. And if you want to learn more about artificial intelligence, I recommend you this book. It's the Bible of Artificial Intelligence. It has been used by many universities, and it has been there for over 10 years. And it's a book of 1,000 pages about all the techniques to implement human behavior, human traits in the machine, and to simulate intelligence. And because of the use of artificial intelligence, we can say that we are doing computer anthropomorphism. We are using some words that are made for describing humans with the machine. So when we say the machine is thinking about something, or the machine is creating something, or even the machine understands what it's doing, it's only taking these words that were for humans for the machine. And actually, the machine doesn't do it under the hood. But the interesting thing about artificial intelligence is that this research gives insight on humans, animals, and physical computer. What is the difference between a machine and human? And at the end, are we just Turing machines? So a Turing machine is a very simple model of a machine, and it only processes symbols on some sort of a tape. It processes it and creates new symbols, and maybe evolution just gave us some predefined rules to live in our world, and are we just a set of rules, or are we more? And artificial intelligence is pushing the boundaries of what makes us human compared to a machine. And any techniques are possible. This is why it's a multidisciplinary field of study. We can use any techniques in applied mathematics to try to achieve this goal. And one of the most important property of human and animals is learning. And machine learning is about how to simulate learning from examples on the machine. And in fact, in this book, it's only 161 pages over the 1,000. So when the book was written, people did not realize how learning was important to simulate intelligence. And the goal is that I will have some examples taken from reality, and I will provide it to an algorithm, and the algorithm would try to learn something from it, something useful from these examples, by using a learning process that is very close to trial and error. And without a doubt, it's the most active subfield of artificial intelligence in terms of research and also industrialization opportunity of the research and the new techniques. And deep learning is a set of machine learning techniques, so it's a subset of machine learning that implement the idea that learning in high-dimensional space. So high-dimensional, you can just think about a high-resolution image or videos. And learning with this kind of data occurs with some representation that we call distributed representation. We will see clearly what they are. And these distributed representation would be computed with specific architectures. So when you see a new model of deep learning, you will see tiny boxes linked together. This is what we call an architecture, and they implement the learning of distributed representation. And before the deep learning revolution, we were talking about artificial neural networks. So for you who are doing machine learning for more than 10 years, you probably know artificial neural network. And when this book was written, it was just 9 pages over the 1,000. So there was really a paradigm shift where 10 years ago, people realized that deep learning was something that really works for complex data type, and now it's taking more and more place in artificial intelligence. And if you want to learn more about deep learning, I recommend this book. It's freely available on this website. It has been written by Jan Goodfellow during his PhD at Mila, and with co-author Yosha Benjo and Aaron Corville. They are covering many concepts that you will see today, but with more details in terms of mathematics, in terms of how the concepts are formalized mathematically.